Here we're going to continue with Worksheet 4. In the last video we used quadratic functions to help us solve area problems. Now we're going to use them for a different type of problems called revenue. Keep in mind quadratic functions are going to be written in general form. So it's ax squared plus bx plus c. And this is general form. And similar to the last type of questions we were doing, we would use the quadratic formula that we come up with, and either we find a graph that pointed up, or we would find a graph that would point down. We would then find the axis of symmetry and use that to help get both coordinates of the vertex. So an x value and a y value. So you would gain on the axis of symmetry, and that would give you an x and y value. And remember the equation of the axis of symmetry, negative b over 2a. Same idea is going to happen here. So revenue questions before we start. Revenue would be the money that you charge, so a cost that's charged to a customer, and then some item that is sold. So if I was selling, let's say I sell salmon flies, okay? Cost of a fly might be $3, and if I sell 40 flies, then that would be $120 revenue. Alright, now could be anything you're selling, right? So within these questions, look for something, the costs that you're selling, and then the number that are sold. Find that first. Alright, so local charity sells reusable water bottles as a fundraiser. They typically sell 1,200 bottles a year at a price of $20. The survey students found that for every $2 increase in price, there would be a drop of 60 sales. At what price should the charity sell the bottles in order to receive a maximum profit? Okay, so let's look for that same information again now. So for R for revenue, what's the cost? $20 for a water bottle. How many do you normally sell? 1,200. So normally they would charge $20 and end up selling 1,200 water bottles. And that will give them a revenue of $24,000. However, they figure, you know what, if we, and let's read the question again, a survey students indicates for every $2 increase in price. So increase the price by $2, they'll lose 60 sales. So if they increase the price by $2, then they expect that they'll lose 60 sales. So it's not the 1,200, or sorry, 24,000 anymore. It's going to be $22 for a bottle. But the sales dropped by 60, so they're down to 1,140 bottles sold. However, they will make more money. So $25,080 versus the $24,000. Okay, not bad. But how many times can they keep doing this? So it may take you a while to figure it out. So you go, okay, well, originally the price was $20. Let's increase it again by another 2. So they increased it by 2. Let's do that twice. So really, I'm going to put the price at $4. And instead of losing 60 people, they're going to lose 120 people. Because now they've done it again. So you've added $2 on here, lost 60, add on another $2, lose another 60 people. And you keep that process up until you find out what the maximum revenue is going to be. When you start losing money, well, then you went too far. That could take a while to figure out. So we're not going to go down that road to do that. So let's look at this slightly differently. Just slightly. So it's going to be revenue. So it's still $20 a bottle. And 1,200 sold. Let's use the information. You increase the price by $2 and lose 60. And here's where you need to follow. You don't know how many times you're going to increase the price by $2 and then lose 60 people. Look right here. How many times are you going to do this? I don't know. That's where we use the variable n. N is going to represent the number of times you're going to increase the price and then, as a result, lose people. So anytime we introduce a variable, so it's just the n is only there to count the number of times that you're increasing the price. So n, and you have to do this, you have to state what a variable is for. N equals number of price increases. So we would have to state that. So you do have a quadratic function here now. This is in factored form. You looked at that last year. Well, it's quadratic. What we need to do, though, we're going to simplify it a little. So we're going to carry any multiplications that we can. So let's get rid of this. We take our 20, multiply it to 1,200. We take our 20 and we multiply it to negative 60. That's the first half. So 20 times 1,200. Plus 20 times negative 60. Now that we multiply the 20 to both terms in the second bracket, we take the 2n and multiply that to both terms. So 2n times 1,200. And then 2n times negative 60n. So 4 terms here should be 4 sets of multiplication below. 20 times 1200 is 24,000, and do not let big numbers throw you off, nor should you let really small numbers throw you off. 20 times 60, negative 120n. 2n times 120 is 2400n. And 2n times negative 60n, negative 120n squared. Okay, so let's put this in, it's just about completely in general form, but we're going to put the squared term first. So we have minus 120, or negative 120 n squared. So it's be 1200n here. Sorry for that. So 1200n, negative 1200n plus 2400n is 1200n plus 24,000. So we have our quadratic function. And it is negative, which means it's a situation like we had here. Like here. So the graph is going to point down. And let's just customize this a little for what we're doing here now. So here's what we know. The graph points down. Our revenue is going to be here. So what is your maximum revenue? Your maximum revenue occurs at the top of the graph. It's the highest point, the highest revenue. And when does it occur? Well, that's at your axis of symmetry here. And what values are represented here on this axis? Well, n. And n stands for the number of price increases. So how many price increases do you have to go through to give you the maximum revenue? So we find our axis of symmetry. We then go take that number, put it back into our equation, and it will give us our maximum revenue. So get your axis of symmetry. Axis symmetry. Alright, just pause that so I can reposition the page there. Okay, now we need to find our axis symmetry. So n equals negative b over 2a. And if you find it helpful, you can write out your a, b, and c values. So your a is negative 120. Your b is 1200. And your c is 24,000. So negative 1200, 2 times negative 120. So negative 1200 over 2 times 120, or negative 120, negative 240. Which comes down to 5. So we have to go through 5 price increases to get the maximum profit. So if we think back to our graph here, the y-intercept is always your c value, so it's 24,000. The graph goes up and it comes down. Axis of symmetry will come down and tell me 5. So it's 5 price increases. Then we use the information to get what our maximum profit would be. or revenue. So there's two versions of the formula you could use. You could use it when it's in standard form or factored form. And factored form was here. Both will give you the maximum revenue. And just to show you that, I'll write out both forms. So let's use our general form. Minus 120. So it's not n anymore, it's 5. $1,200 times 5, and then 24,000. So negative 120 times 25, and then 1200 times 5 is 6,000. Plus 24,000. Wow, that's going to give us 30,000 right here. And negative 120 times 25 is negative 3,000. So your profit is 27,000. You could have also used, we said the formula in factored form, and in factored form it was 20 plus 2n and 1200 take away 60n. So 20 plus 2 times 5. Just be careful for your brackets here. You got the 2n, hit this in a bracket there. And then 1200. 60 times 5. 20 plus 2n. So 20 plus 2 times 5. The 2 times 5 is 10 plus 20. That's 30. Then 120, or sorry, 1200 take away 300. 60 times 5 is 300. 120 take away 300 is 900. And then we have 27,000. So either form doesn't matter. Now remember to read the question again, RTQ, and make sure we answered what we were asked. At what price should charities sell the bottles in order to maximize profit, and what is the maximum profit can be made? Well, there's a little advantage in doing the factored form here. If you remember that this is the cost of the bottle that you're selling it at and number sold. So if you sell each bottle for $30 and sell 900 of them, you will get a maximum profit of $27,000. So this you could state as an answer. Sell bottles for $30 each. Earning $27,000.